So my name is Adam. I'm an iOS developer in Netguru. And today I want to briefly tell you about the missing collection view in SwiftUI. Why is it missing? I will tell you in a minute, but let me just quickly tell you what the presentation will be about. So first, I will briefly introduce you guys the SwiftUI topic because I assume some of you may not know it because not all of you are iOS developers. Then I will tell you what is the current state of the collection view in SwiftUI, and then I will tell about my research, of course. So, what is SwiftUI, you may wonder? Basically, it's a new framework developed by Apple to develop UI in very flexible, fast and enjoyable way. But to better introduce you to this topic, I would like to show you a quick video from this year WWDC, so the biggest Apple conference in a year, when Craig Federighi, the guy in the picture, will tell you what the SwiftUI is about.
For instance, let's take an app like this, a simple list. We've all written one of these. Now, it turns out if you want to write this with support for all the modern features, you might end up writing something like this in UIKit. It's actually quite a bit of code. Here's that same thing in SwiftUI. That's it. Just a few lines of Swift code. Yes. Now, there's so much that SwiftUI gives you. It frees you to focus on the functionality in your apps. And we automatically do new things for you. Like when we add dark mode, your app gets it automatically. And of course, the framework is only part of the story. Because in Xcode, there's a new interactive development experience. You can think about it like playgrounds, cranked to 11, built for apps.
So, as you saw, this framework is pretty amazing, pretty powerful. It reduces the amount of code written while developing UI, and you might imagine that the iOS community was pretty psyched about it. But let me tell you what the fuss is all about in details. Basically, SwiftUI is nice for the beginners to get started with developing the UI because you don't have to write all the boilerplate code. You just have to write simple few lines of code to get started. It's because of that it's extremely easy. It's also very fast to develop UI in this framework. We are able to write whole views in a matter of hours, maybe minutes, instead of like days, I don't know. Also, it's fast when refactoring. You can easily extract views, you can remodel it the way you want, you can apply many modifiers and basically shape the thing as the way you want. It's also different from the old good UI kit because the UI kit, the basic framework for defining UI in Swift, is imperative and SwiftUI is declarative. The difference is quite significant because it allows us to don't worry about several things while developing the UI. It also, as you saw on the video, has a kind of two-way design canvas. It works in a way that you can basically put the things on the screen of the app, like we are used to in Interface Builder in many other languages, but it doesn't generate the XML file, it generates the code itself. So you can see while putting a label on screen of the app, you can see the label appearing in code, and it works both ways, of course. And the only downside is that it's a bit raw, it's still new, and it works only from iOS 13, so the newest Apple ecosystem. But let me tell you a secret, it's not like a biggest downside because, well, in Netguru we already developed one app using SwiftUI, so it's quite nice. Okay, coming back to the main topic, what do we say to collection view in SwiftUI, you may ask? Well, Apple has an answer for that, which is no. We don't have a collection view, the one we love, the one that was introduced several years ago, and all developers fell in love with it. Well, at least not today, because as you may expect, the framework will evolve, and probably maybe in June we will get the collection view in SwiftUI. What is the state of the art, you may ask? Actually, Apple has an answer for that, and I will briefly present it to you, the Apple approach. According to Avery Wine blog, which link you can find on the bottom of the slide, you basically have to represent the collection view inside SwiftUI, the old collection view we know, and in order to do that you need to use UI view representable protocol and just wrap the UIKit collection view around it. You create it in the way we all know, blah blah blah, you know, nothing really interesting. And then you create a coordinator that is responsible for feeding the collection view with the data. Well, I don't think it's sexy as SwiftUI should be, and that's why I started to dig deeper. The first approach I thought about is just stacking and scrolling, because SwiftUI offers some views already. And I started from the point that maybe the simplest solution might be the best, and I started digging in. Before I tell you how I did it, I would like to mention this beautiful library made by one of Polish developers, actually based in Warsaw. Maybe he's even here, I don't know. His name is Karol Kulesza. It's KuGrid. You can find it online on GitHub, and it works pretty well. Well, if you want this kind of collection view, it's really good. Test it and customizable. So I strongly encourage you to use it. But coming back to the topic. Is the simple solution sometimes best? To implement, let's say, easy collection view that we like, so you know, some cells, swipeable left and right, beautiful layout, we just need scroll view plus HStack. These are two, let's say, basic views of SwiftUI. And by combining these two, we get something very simple. We just need to represent the model, we create a image cell view, and then we just put it all around. Pretty easy, huh? It's like writing it in 10 minutes and you got all the collection view working, and the effects are quite nice, I might say. It works pretty well. You can also have it in vertical, just by changing two properties from horizontal to vertical and from HStack to VStack. It works nice, but I wouldn't actually implement the vertical one because you have a list for that in SwiftUI. So, is the simple solution sometimes best? Well, to be honest, I don't know. It depends on what you want, of course. If you just want to have it in one view, then fine. But it wasn't enough for me. I wanted something deeper. I wanted to have lazy loading, which this approach didn't have. I wanted to have different layouts, like we all know from the Apple libraries already. And I wanted to have it generic, so I can just reuse it everywhere I want. So I said, no, I will not accept that. And I started to dig even deeper. And that's where we come to my research. I will first show you what I achieved in the matter of these requirements I gave myself, and then I will just tell you how I did it. I strongly recommend you to use this app. It's beautiful if you are Pokemon fans as me. It's Poke app. You can find it in Google, and it's free to use. So let's do it. Okay, so that was lazy loading, as you might saw. Then different layout styles of collection view, the one that we all know from App Store, the flow layout, or the single line layout that we already saw, but this time it's implemented a bit different. And also, I wanted it to be generic. So that's where I landed with something like this. It's all the same object rendering these collections. You just give him data and, let's say, a prototype of collection view cell, and then you have something like that. These assets in the right bottom corner are from Ray van der Lisch. Maybe some of you even know them from some tutorials. Anyway, coming back to the topic. While implementing my collection view in SwiftUI, I focused on the basic object. You might see this around the presentation in a further point. Basically, in SwiftUI, the views are structs. It's a difference from the UI kit where the views are class. They need to implement the view protocol, and in order to make it generic, I needed random access collection. I needed some generic view, and I needed the elements of the random access collection to, of course, be identifiable so the loops can identify them. And also further in the presentation, there would be a point where this massive type alias will appear. It's basically a dictionary that represents the sizes of the collection elements. Okay, so what are the ingredients of this beautiful collection view? First one is geometry reader. The thing about SwiftUI and laying it out on our screens is that the views basically don't worry about the size because they are rendered from top to the bottom, from parents to children, and basically the lowest view never really worries about what the size should be because the parent always tells him. But if we want to somehow avoid this or make it in another way, we need something called geometry reader. Geometry reader is actually yet another view that is actually a wrapper view. You may see that there is a self body for that's actually a call to a function that generates later the body of collection view. But what is the most important is that the geometry reader has this secret stashed proxy, which is of type geometry proxy. It basically reads the size of the child that parents want it to have, and we can manipulate it from there. So that's pretty useful. The second ingredient that I needed to have to implement this was preference key. So preference key, you may see it on the bottom, highlighted. It's actually a kind of a struct that reduces values that we give to him, and then returns a dictionary of these values, and we do that in order to attach some attributes to the view itself. Why would we need that? Because if we want to render something from the bottom to top, it's possible, but we need to pass it up the view hierarchy in SwiftUI, and we do that actually using the preference key. And after we have this defined struct, we of course can do it however we want. Then we need this view modifier. In SwiftUI, we generally have like basic views, and then we have tons of view modifiers that we can use, and they basically return another view but modified by the content of this modifier. So the view modifier on preference change, when the preference key is changing, then it propagates the value of it to the parent. And in this case, these are sizes of the elements of the collection view. And the key point is here. The propagate size view is actually yet another wrapper of the cells, which reads the size of the cells and propagates it up the view hierarchy. You might wonder why this preference is attached to color. Well, it's a kind of a hack that we use on SwiftUI to, in some places, put the clear background and read the properties, the size, or I will show you later, somehow hack the UI with the transparent views that are not affected by touch. It's just a color. So that's how we propagate the size up the view hierarchy. But there is a risk in that approach. You might end up, of course, in the recursive loop, because in the first point, your parent tells you, I want some sizes for my children, and then the children says, no, daddy, I don't want this size, I want another one, and then we might end up in a loop, which we need to avoid, but you will understand quickly that you are in the recursive loop because the app will freeze, so it's pretty simple to spot. Okay, the third ingredient. Third, okay. Z-stack. As you saw already before, we have H-stack, which is horizontal stack, we have V-stack, which is vertical stack in SwiftUI, and then finally we have the Z-stack, which offers us, of course, 3 axes, not only the horizontal and vertical, but also the Z-axis. And it's actually pretty important, because if you have only the V or H-axis, you cannot actually lay out the views as you want. You need this ZX, because actually the crucial part of it is using the offset here on the children views. You might see here our old friend from the previous slides, the propagate size, which wraps the actual cell view inside, and then we just lay it out one by one by one by one and so on and so forth. So we get the proper sizing and the proper layout. And here is another background hack using color clear, because this stack, as any other stack, will lay out our views not actually from the top, but from the center of the view. That's the natural way of laying out views in SwiftUI. So in order to tell us, dear ZStack, I want to have the view on the whole screen, we need to use this kind of a hack and just use the container size, which we got from the geometry reader at the first point, and pass it around and make it appear on the whole screen. The fourth ingredient. The fourth ingredient is layout itself, because we need to somehow calculate it. And here comes the solution. I have to say that I was really inspired, and actually the whole code visible on the slide is taken from Swift Talk blog post. I strongly recommend you guys to dive into this. It's actually paid subscription, but they have really valuable content. And this layout struct and functions allows us to calculate the offset and lay out our objects. So we get each object piece by piece, and then we get its sizes and just lay it out and then put it in the ZStack as we saw on the previous slide. What is nice about it? It's that if you look close enough, you might see that it's UI independent. So we might use it as well with UIKit, SwiftUI. It doesn't matter. It just gets the sizes, calculates it. It's just pure math. So we might use it in both frameworks. Fifth ingredient is paged collection, because as you may know or don't know, SwiftUI renders the whole dataset at one point. Just gets the whole dataset and lays it out on the screen, and it might be tricky when you have a collection view with like 5,000 elements. It might freeze for a while, I don't know. So that's why I wanted to have the lazy loading. And I was struggling with that, to be honest. And I came around like a moment of reflection. Why is that not working? I'm just adding the elements, and it just re-renders the whole set again and again and again. So I thought, yeah, obviously it re-renders the whole object because there are structs, and as we may know, the structs aren't passed around. They are just recreated again and again and again in Swift. So that's when I came to some conclusions. First of all, when we generally use SwiftUI, we use property wrappers to handle the data. The most popular one, and the one that we come across in basic tutorials, is the state property wrapper. It just tells our struct view that, hey, this is a property you might watch, and it may change in a while, so you might want to render the whole view when it changes. And it wasn't the solution for me, because it just didn't work, because it was re-rendering the data set and it was laying out wrongly. So I figured out a way to avoid this. And because of that, I needed a wrapper. I needed a wrapper to both the collection, the data set that I was giving to the collection, and the collection itself. So first I created the paged random access collection, which is important that it needs to implement the observable object protocol. It just tells the Swift UI that, hey, something might be possible to observe here, and we need something to be published, wrapped around with published wrapper, and actually Swift will be able to watch this particular object. And then we need to pass this whole paged collection, which is feeding the data to the collection page by page according to what we set the value to. Then we need to put it in the collection view as an environment object. This is another property wrapper, which is basically kind of injecting the dependency of this data set, and it feeds it. It doesn't re-renders the data set over and over again. So that's a way to accomplish lazy loading. And the final ingredient is the configuration related to scroll view. First of all, if we use this stack, it doesn't by default allow you to scroll to the left, to the right indefinitely. It just renders what is on the screen, and you need to handle that. So what I came across on the internet is to use padding here. I just calculate the padding when I enter the function. It is basically the maximum offset. You remember the offsets earlier we calculated it, and now we just get the maximum value, and we put a padding. It depends if you want the horizontal or vertical. You just put it on the bottom or on the trailing edge. It just depends on the direction you want to scroll in. And the other scroll view related issue was that since the SwiftUI, as I mentioned in the beginning, is pretty raw, pretty new, it doesn't offer yet the events handling in scroll view. So I needed to somehow hack it, and that's what I came up with. It's another proper view modifier which we apply to the propagate size, our old friend that is wrapping the collection view cells. And when it reaches the frame boundary, which is actually the same value as the padding from the Z-stack, it just tells the paged collection to give me another piece of data. So there is no event handling, unfortunately, in the scroll view. And well, that's basically it. I will show you now the whole collection view once again, so you can watch the beautiful Pokemons. Yeah, the 6 ingredients that I mentioned are the key ones. Of course, there is some view code, but I didn't want to put too much inside. If you would like to see the whole code, it will be available on my GitHub, as well as in a blog post that I will soon publish on our company Code Stories blog. You can just Google Netguru Code Stories and you will be able to find it somewhere there. So also on GitHub, but before publishing the blog post, I need to clean the code and work on it a bit. So summing up, it's possible, as you saw, to implement the collection view as we know in SwiftUI. Is it worth all the hard work? I would say it depends, as always. Because if you just want a simple collection view, scrollable as we saw on the beginning, just one row, then just go for H-stack and scroll view. Simple as that. You will do it in 10 minutes, not several hours or days. On the other hand, if you want to have plain SwiftUI code, it's possible. SwiftUI, I think, would play a huge role in the future. Maybe not this year yet, but for sure next year, when we would be able to develop apps from iOS 13 up, when there would be no more supporting of older versions in general. So I strongly recommend to dive into that, because this exercise also taught me some basic SwiftUI concepts. And in the end, if you want to be pixel perfect, you want to be sure that you handle all the events properly, stuff like that, then go for the Apple approach. I know it's not the funniest thing to do, but it's very strict and very precise, so it will be good in the end. Okay, any questions?
Did you try running this on macOS?
No, I did not. I was just developing for iPhone, so I didn't try, to be honest. Simple as that.
I've experienced some, let's say, things that were working on iOS, but they weren't on macOS. And, well, there is pretty no much documentation. So
yeah, that's right. The SwiftUI is not well documented. Actually, on this previous post, when you saw the scroll view plus H stack, if I remember correctly, that was the whole documentation of these two objects that I pasted there. So it's not well documented yet. Luckily, there are a lot of tutorials that people go through these objects, and you may work on that. But yeah, Apple, let's say, didn't manage to deliver us the documentation we would love. Any other questions, guys? If not, feel free to contact me. Thank you for your attention. And if you want to see the whole code, as I said, my GitHub or just post me a note on my email and I will notify you when it's available. Thank you very much.